Hi friends, today we're going to talk about absolute value inequalities. Now, I have another video on absolute value equations. If you haven't watched that yet, I'd like to encourage you to watch that as it will get you a little more comfortable dealing with absolute values. All right, so remember when we have an absolute value and we are solving using an absolute value, we are always going to end up with two cases. That's how we break up that absolute value. So, just like with absolute value equations, we start solving absolute value inequalities. Our first step is isolate the absolute value. We want to get it all by itself on one side of the inequality. Then, once we have done that, we're going to break it into two cases. And the way I like to think about this, there's lots of ways to explain it. I like to think of it as replacing the absolute value with positive and negative parentheses. So whatever is inside the absolute value, I'm going to rewrite it with a plus and minus on the outside of parentheses. And then we are going to solve both cases. Now, usually, our answer is going to be in interval notation. And if you are not familiar with interval notation, I have another video that talks about interval notation and writing that. All right, so let's throw up some examples and work through them. All right, we've got some examples to go through. Now, one thing that we want to keep in mind as we are doing this, we are dealing with either less than or equal to, or greater than or equal to. When we are dealing with less than, I like to write it as less than. Okay, do you see the and in there? That means that our two cases are going to be joined by an and. This will make more sense when we see an example. The other opportunity is that we have a greater than. These means our two cases are going to be joined by an or. So don't worry. All right, so first example, I have absolute value of x minus 5 is less than 3. All right, so we have isolated that absolute value. We're going to break it into two cases, and instead of putting x minus 5 in absolute value bars, we're going to write it as plus or minus parentheses x minus 5 is less than 3. Now we're going to go to our two cases. So positive of x minus 5, that was a 5. Jumped right to that 3 there. All right. X minus 5 less than 3. And then I have negative of parentheses x minus 5 less than 3. And in between the two of them, I have a less than. So less than, we're going to write the word and. And it's going to change how we interpret our answer. All right, let's solve both of these inequalities. For the first one, x minus 5 is less than 3. Adding 5 to both sides, I get x is less than 8. The second one, I have negative of x minus 5 in parentheses, less than 3. I'm going to multiply both sides by negative 1. So I have x minus 5 is greater than negative 3. Remember, when we multiply or divide by a negative number, our inequality flips. All right, I'll add 5 to both sides. So I get x is greater than positive 2. Remember that these are joined by an and. So we want the region that is true for both statements. So I'm going to draw a number line just to make this easier to see. All right, so my first statement, x is less than 8. I have my number line with 2 and 8 marked on it. I'm going to do an open circle at 8, and I'm going to mark to the left to indicate x less than 8. And I did that in yellow. We're going to do the second one in orange, just to make it a little easier to see. So x greater than 2, we're going to do an open circle at 2. Greater than 2 would be shaded to the right. And remember, we're looking at and, so where they are both true. That would be the region that has been shaded twice in both orange and yellow. So it would be this region between 2 and 8, but not including 2 or 8 because I have an open circle on both of those. So writing that in interval notation, I would have parentheses 2, comma, 8, close parentheses. And that would be my answer to this inequality in interval notation. Okay, let's look at another one. My next example, I have 2 times the absolute value of 3 minus x plus 1 is greater than or equal to 5. So the first thing we want to do is isolate that absolute value. I'll subtract 1 from both sides. So I have 2 times absolute value of 3 minus x is greater than or equal to 4. I need to divide by 2 to isolate that absolute value. So I have absolute value of 3 minus x is greater than or equal to 2. Now, notice I divided by a positive number, so the inequality stays just as it is. It only flips if I divide or multiply by a negative number. All right, let's go to our 2 cases. So this would be plus and minus, parentheses, 3 minus x, greater than or equal to 2. Notice we have a greater. So we are going to write the word or between our 2 cases. So the first one is 3 minus x greater than or equal to 2, or negative of 3 minus x greater than or equal to 2. I'm going to go ahead and switch the second case and rewrite it as 3 minus x greater than or equal to negative 2. And I made an error right there that I've been telling you not to make. Remember that when we multiply or divide by a negative number, we switch the inequality. So it will be 3 minus x less than or equal to negative 2. All right, let's solve them both. So I'll subtract 3 from both sides. So I have negative x greater than or equal to negative 1. Divide by negative 1. I have x less than or equal to 1. For the second one, again, I'll subtract 3. So I have negative x less than or equal to negative 5. Multiply by negative 1. I have x greater than or equal to positive 5. Okay, I always like to draw a number line because I feel like that makes it easier to see. And I'm going to mark 1 and 5 on that number line. And just like I did before, I'm going to shade these in 2 different colors. So x less than or equal to 1, I'll do in yellow. Because it is less than or equal to, I have a solid dot. Less than is to the left, so I'm going to shade to the left and include that arrow. X greater than or equal to 5, I'm going to mark in orange. because it's greater than or equal to, I'll have a solid dot. It's greater than 5, so that will be to the right. And I'm going to also shade the arrow. All right, so looking at this number line, we have two regions, and because they are joined by an or, either region is a solution. So we would write our answer as the interval from negative infinity up to 1 with a bracket, or, which we write as the union symbol, 5, because it is included, 5 gets a bracket on its side, up to infinity, close parentheses. And sometimes it's helpful to mark that left arrow as negative infinity and the right arrow as positive infinity, because it can make it easier to read those intervals off of your number line, just like that. Okay? So I can fill in those parentheses and brackets under the number line, and it makes it easier to transfer my answer. All right, let's try a couple more examples. So always first, we have to isolate that absolute value. I have 2 times absolute value of x plus 1 plus 3 less than 9. First, we'll subtract 3 from both sides. And I have 2 times absolute value of x plus 1 is less than 6. It's almost isolated, but not quite. We're going to divide 3 by 2. And I have absolute value of x plus 1 is less than 3. All right, our absolute value is all by itself. Now we look at, do we have less than or greater? Well, I've got a less than. So that means that our 2 cases will be joined by an and. Remember that we cannot do this until we have isolated the absolute value. So we have to isolate it first before we know if we have a less than or a greater. All right, so first case will be x plus 1 less than 3. And then we have an and then negative of x plus 1 is less than 3. Okay, remember absolute value always splits into positive parentheses and negative parentheses. Let's solve both of those. I'll rewrite them up here. So x plus 1 less than 3 and negative of x plus 1 less than 3. All right, so on the left one, x plus 1 less than 3. We'll subtract 1 from both sides, and I get x less than 2. My other inequality, I'm going to rewrite this as x plus 1 greater than negative 3, because I multiplied through by negative 1. And then I'll subtract 1 from both sides and get x greater than negative 4. All right, time to go to a number line. On that number line, I'm going to mark negative 4 and 2. And remember, we're looking for the and, so we want to look for the part of the number line that's shaded both times. So I'll start with x less than 2. Less than 2, I have an open circle at 2, and I'm going to mark to the left. X greater than negative 4, I'll have an open circle at negative 4, and I'm going to shade to the right. Notice that the piece of the graph that was shaded both times, because we're looking for the and situation, is negative 4 to 2. So my answer would be parentheses, negative 4, comma, 2, close parentheses in interval notation. All right, let's tackle another one. Here I reverse the order on you. Don't be thrown off. We can still do this one. So I have 4 minus absolute value of x minus 2 less than or equal to 1. First, we have to isolate that absolute value. So I'll subtract 4 from both sides, I have a negative absolute value of x minus 2 is less than or equal to negative 3. Don't lose that negative on the front of that absolute value. It's very important. All right, absolute value is still not by itself yet. We need to multiply through by negative 1. So I'll have absolute value of x minus 2 is greater than or equal to positive 3. Remember, when we multiply by a negative number, it changes it switches the inequality. All right. Now, in this situation, we have a greater. We have a greater than symbol. So, absolute value greater than a number. That means we're going to have an or between our two cases. So we'll have x minus 2 greater than or equal to 3, or negative of x minus 2 greater than or equal to 3, which we can rewrite as x minus 2 less than or equal to negative 3. And we'll solve both of those. All right, starting on the left one, x minus 2 greater than 3. Let's add 2 to both sides, and I get x is greater than or equal to 5. On the other one, x minus 2 less than negative 3, we'll add 2 to both sides, and I get x is less than or equal to negative 1. Let's draw that number line, and I'll mark negative 1 and 5 on it. Remember, we've got an or situation, so any area that is shaded is a solution. First, I'm going to shade x greater than or equal to 5 by placing a solid dot at 5. Because it is greater than, we're going to shade to the right and include that arrow. And I'll mark that as positive infinity, because I'm getting ready to go to that interval notation. The second one, x less than or equal to negative 1. We'll start with a solid dot on negative 1. It's less than, so we will go to the left. And I'm going to go ahead and label that left arrow as negative infinity. All right, so from my number line, I can add a parentheses on negative infinity and a comma between that and negative 1 and a bracket on negative 1 to indicate that we have a solid dot. So that's the first piece of my solution. And then we will add in the second piece, which is bracket 5, comma, positive infinity. Okay. All right. One more regular one, and then I've got a few weird cases for you that I really think you should see. So, next example, absolute value of 3x minus 2 plus 1 less than or equal to 5. Always isolate the absolute value first. We'll subtract 1 from both sides. So I have absolute value of 3x minus 2 is less than or equal to 4. All right, this is going to be broken up into two cases, plus and minus parentheses, 3x minus 2 less than or equal to 4. All right, we have a less than situation, so we'll have and between the two cases. So 3x minus 2 less than or equal to 4, and negative of 3x minus 2 is less than or equal to 4. I'm going to go ahead and rewrite that as 3x minus 2 greater than or equal to negative 4. Hopefully you guys are comfortable with that switch at this point. All right, let's solve them both. So 3x minus 2 less than or equal to 4, I'll add 2 to both sides. 3x less than or equal to 6, and x is less than or equal to 2. Let's jump to the other case. 3x minus 2 greater than or equal to negative 4. We'll add 2 to both sides. I have 3x greater than or equal to negative 2. Divide by 3 to get x is greater than or equal to negative 2/3. All right, remember we have an and between them, so we want the part of the graph that they both share, that is shaded both times. I'll draw my number line. And I'm going to mark negative 2/3 and positive 2 on that number line. So I'm going to shade x less than or equal to 2 in the yellow. Because it's less than or equal, I'll start with a solid dot on 2. And I'm going to shade to the left to indicate less than. Next, I'll shade the x greater than or equal to negative 2/3. Because it's greater than or equal to, I'm going to start with a solid dot on the negative 2/3. And it's greater than, so I will shade to the right. And I'm going to mark that right arrow as positive infinity. Okay, so we want the part that is included in both. That will be the region between negative 2/3 and up to 2. Because they both have a solid dot, we will have brackets on both ends to indicate that we are including both endpoints of negative 2/3 and 2 in our answer. All right, let's look at some weird cases. They don't look weird, not yet. Hang tight. All right, so my first one is 2 times absolute value of x plus 8 plus 10 is less than 10. Isolate that absolute value. I'm going to subtract 10 from both sides, and I'll get 2 times absolute value of x plus 8 is less than or equal to 0. We got a 0. That's weird. All right, let's divide by 2 on both sides, and I have absolute value of x plus 8 is less than or equal to 0 still. All right, so much like in the absolute value equations, when you have this equal to 0, we only have one case. So we have x plus 8 is less than or equal to 0. Well, an absolute value can't be negative. So the only option here is that it is equal to 0. Because absolute value is always a positive number. So we cannot have less than 0. We can only have equal 0. And this will give us one single solution of x equals negative 8. That is our only solution to this inequality. Told you it was weird. All right, let's look at the next one. Absolute value of x plus 1 plus 5 is less than 5. All right, let's isolate that absolute value. I'll subtract 5 from both sides, and I've got x plus 1 in absolute value is less than 0. Okay, well that's weird. Absolute value can only be positive or 0. It can never be negative. So there are no x's that we can put into this absolute value in order to have that absolute value be less than 0. So this is a big ol' nope. And mathematically, nope does not exist. D-N-E. Okay. Another one. This is my last weird one. So I have 2 times absolute value of x minus 2 minus 1 is less than negative 13. Now remember, we cannot declare anything until we have that absolute value by itself. So there's no way I could look at this and be like, oh, there's a negative, it's weird. We've got to isolate it first. All right, so let's add 1 to both sides. So 2 times absolute value of x minus 2 is less than negative 12. We'll divide by 2. So absolute value of x minus 2 is less than negative 6. Well, now we have something strange. I have an absolute value that cannot be negative less than a negative number. Can't happen. All right, that one's another big ol' nope. So mathematically, we write D in E for does not exist. Okay, hope this is helpful on solving absolute value inequalities. If you need additional resources on absolute value equations, that video is out there. And then also number lines and graphing inequalities also have their own video.